Did you know a single misconfigured ACL could block all your network traffic? Standard ACLs are powerful security tools, but one wrong command can cause chaos. In this video, I'll show you the exact step-by-step method to configure them properly, including the secret most beginners miss about named ACLs. Watch now and never accidentally lock yourself out of your network again. Standard ACL configuration. Standard ACLs are configured on a router in global configuration mode. The access list command creates an ACL entry. Here, in the example, the 172.16. 2 times 0 network combined with a wildcard mask in 2 times 0. 2 times 255 indicates any source address that starts with 172. We have seen that a standard ACL is numbered from 1 to 99 or from 1300 to 1999. In the example, we have chosen to name it in 1. The output of the show access list command displays the ACL that are currently configured on the router. To delete an ACL, you need to do no access list plus its ACL number in global configuration mode. And if we make a show access list again, it confirms that the ACL is removed. An ACL can contain multiple rows. However, it is not possible to delete a line individually, at least for numbered ACL. The no access list plus the ACL number deletes all the content of the ACL. The only way to remove or modify an ACL would be to copy all the lines of the ACL into a text editor to edit it. Then delete the ACL on the router and copy-paste the new ACL that you will have modified in the text editor. On the new versions of the iOS, the editing of an ACL is simplified because they now use sequential numbering. Thanks to the ACL, it is therefore possible to filter network traffic to limit or restrict access to a network resource. The ACL allows access to be controlled based on Layer 3 information, which is contained in the header of the IP packet. With a standard ACL, it is possible to prevent IP packets from either entering or leaving the router. Here is a small diagram which explains the difference between placing the ACL in or out of the interface. In an outbound ACL, the packets that enter the router are processed first and foremost by the routing table. If the packet's destination network is not one of the networks that are in the routing table, then it will be deleted. And if a match exists, it will be sent to the ACL. And the same goes for the ACL. If the packet is allowed, then it will go to the exit interface. Otherwise, it will be deleted. And for an incoming ACL, here, the packets are first processed by the ACL before being sent to the router. After configuring an ACL, it must be applied to an interface using the IP access group. The IP access group 1 out command applies ACL Enigarigna 1 on the output interface, and the IP access group 2 in command applies ACL number 2 to the input interface. There can be only one ACL per protocol, per direction, and per interface. Let's take an example. On this topology, we want to cut off internet access to the PC with the IP 192.168.1.1 while allowing other PCs on the same LAN. To do this, it is possible to apply traffic filtering on the router, either inbound, i.e. on the interface that is connected to the local network, or outbound, on the interface connected on the internet side. Since the reading of an ACL is done from top to bottom, we will create the first entry by refusing the PC, and the second by allowing all LAN 192.168.1.24. Then, we have plus to apply this ACL as an output on the fast Ethernet 0.1 interface. you will notice that the ACL has been placed on the router's output. We could have very well positioned it directly on the fast Ethernet serial input. This would still prevent the point 1 PC from accessing the internet, but the problem is that it would also have prevented it from communicating with the router. For those wondering, our second line of the ACL is essential, because implicitly, for security reasons, the last entry denies any passage. Basically, if no entries are matched, the packet is deleted. That's why in our example, it was important to add a line that allows everything else in the network. Instead of declaring our standard ACL with a number between 1 to 99 and 1300 to 1999, it is possible to assign a name to it. This is called an ACL named. This allows you to have a description of the function of the ACL, which can be very useful when you have several. The command to create an access list named is IP access list standard plus the name we want to give it. In the example, it is called Internet PC1. We can't be clearer than that. The name we give to the ACL must be unique. You will notice that the acronym has changed. We are now in the configuration mode of our ACL. We can now write our ACL lines one by one. The main advantage of a named ACL is that each row you enter is numbered from 10 and incremented by 10 for the following ones. Our deny line will have 10 on it, and the line below it will be numbered 20. Thanks to this, it is possible to delete or modify a line without having to delete the entire ACL, and all we have to do is attach our named ACL on the interface. It is the same command, except that instead of the number, you put the name. If we do a show access list, we can see that our two ACL lines each have a sequence number. The big advantage is that if you want to ban the internet for another PC that would have the IP 192.168.1.2, you will just have to place your ACL line just before the permit, numbering it with a number less than 20. In the example, we have taken the sequence number 5. This way, if we do a show access lists again, our last ACL is placed above the first one. It is also very easy to delete a single line from the ACL without having to delete it completely by simply making a no plus the sequence number to be deleted. To do, of course, in the ACL configuration mode. And we're going to finish with the command access list resequence, which allows the updating of these sequence numbers without restarting.